Hormones are chemical compounds secreted into the blood that affect target tissues, generally at a site distant from original production. Multiple hormones can affect one physiological function, like carbohydrate metabolism under the control of insulin, glucagon, growth hormone, cortisol, and epinephrine. A single hormone can affect several organs to produce different physiological effects, such as cortisol. There are three classes of hormones: steroids, proteins which include peptides or glycoproteins, and amines. Steroid hormones are synthesized by adrenal glands, gonads, and the placenta. They are synthesized from cholesterol as needed, not stored, and are lipid-soluble. They need a carrier protein to circulate in the blood. Clinically significant hormones include cortisol, aldosterone, testosterone, estrogen, and progesterone. The mechanism of action involves the free hormone being transported across the cell membrane to interact with an intracellular receptor. This complex then binds to chromatin, producing mRNA. The mRNA initiates the production of proteins that carry out the function attributed to the specific hormone. Hormone synthesis is regulated through negative feedback by another hormone, for example, cortisol and ACTH. Protein hormones are synthesized by the anterior pituitary, placenta, pancreas, and parathyroid glands. They are synthesized, then stored in the cell as secretory granules until needed. These hormones do not need carrier proteins to enter the blood because they are water-soluble. Clinically significant hormones include follicle-stimulating hormone, luteinizing hormone, thyroid-stimulating hormone, human chorionic gonadotrophin, insulin, glucagon, parathyroid hormone, growth hormone, and prolactin. Glycoprotein hormones, such as follicle-stimulating hormone, luteinizing hormone, thyroid-stimulating hormone, and human chorionic gonadotrophin, are composed of alpha and beta chains. The alpha chains are identical, while the beta chains are unique for each hormone. Peptide hormones are synthesized as prohormones and are cleaved to produce the circulating hormone, like insulin. The mechanism of action for protein hormones involves interacting with a cell membrane receptor. This interaction activates a second messenger system, leading to cellular action. Hormone synthesis is regulated through changes in analyte concentration in serum, such as insulin with glucose, and through negative feedback by another hormone, such as testosterone with follicle-stimulating hormone. Amine hormones are synthesized by the thyroid and adrenal glands. They are synthesized from amino acids. Some amine hormones require a carrier protein, while others do not. Clinically significant hormones in this category include epinephrine, norepinephrine, thyroxine, and triiodothyronine. The mechanism of action for epinephrine and norepinephrine involves not binding to carrier proteins and interacting with the receptor site on the cell membrane. In contrast, thyroxine and triiodothyronine circulate bound to carrier proteins, with the free hormone being transported across the cell membrane to interact with the intracellular receptor. Hormone synthesis in amine hormones is regulated by nerve stimulation, another hormone, such as thyroxine with thyroid-stimulating hormone, and negative feedback. Methods for quantifying hormones need to be sensitive because of the extremely low levels of hormones in the circulation. Some of the more commonly used methods include enzyme-multiplied immunoassay technique, fluorescent immunoassay, fluorescent polarization immunoassay, chemiluminescent immunoassay, electrochemiluminescence immunoassay, and high-performance liquid chromatography. Hypothalamus overview and clinical significance. So let's dive in. Hormones produced by the hypothalamus and their function are quite fascinating. First, we have corticotropin-releasing hormone, or CRH, which stimulates the secretion of adrenocorticotropic hormone, commonly known as ACTH. Then there's gonadotropin-releasing hormone, or GnRH, which stimulates the secretion of follicle-stimulating hormone, or FSH, and luteinizing hormone, or LH. Next is growth hormone-releasing hormone, or GHRH, which stimulates the secretion of growth hormone, GH. Thyrotropin-releasing hormone, TRH, stimulates the secretion of thyroid-stimulating hormone, TSH, and prolactin. Dopamine, interestingly enough, inhibits prolactin release. And finally, somatostatin inhibits the secretion of TSH and GH. Quite a lineup, isn't it? Now let's talk about diseases. These include tumors, inflammatory or degenerative processes, and congenital disorders. It's a complex and critical area of study. Anterior pituitary, overview and clinical significance. Hormones secreted by the anterior pituitary include adrenocorticotropic hormone, luteinizing hormone, follicle-stimulating hormone, thyroid-stimulating hormone, growth hormone, and prolactin. Adrenocorticotropic hormone. Corticotropin-releasing hormone stimulates secretion of ACTH, which in turn stimulates synthesis of cortisol. Increased cortisol levels turn off secretion of ACH and CRH. Decreased cortisol levels stimulate secretion of ACTH through negative feedback, which promotes cortisol synthesis. ACTH and cortisol exhibit diurnal variation, with highest levels in the morning and lowest levels in late afternoon to early evening. Growth hormone, also known as somatotropin. The hypothalamus controls the release of growth hormone from the anterior pituitary, with growth hormone releasing hormone, which is stimulatory, and somatostatin, which is inhibitory. Growth hormone has a direct effect on metabolism in numerous tissues. It has an antagonistic effect to insulin in relationship to glucose metabolism, stimulates gluconeogenesis in the liver, stimulates lipolysis, and promotes protein synthesis. The reference range for basal levels is 2 to 5 nanograms per milliliter. Clinical significance. Increased levels in childhood result in pituitary gigantism and in adulthood in acromegaly, which includes symptoms like enlarged feet, hands, and facial bones, impaired glucose tolerance, and hypertension. Acromegaly is generally caused by a growth hormone-secreting pituitary tumor. Decreased levels in adults can be caused by pituitary adenomas or irradiation, while in children it may be familial or caused by a tumor such as craniopharyngioma, resulting in pituitary dwarfism. Prolactin is secreted by pituitary lactotroph cells and released upon stimulation from thyrotropin-releasing hormone. Dopamine inhibits its release. The function of prolactin is to initiate and maintain lactation. It also affects reproduction through ovarian and testicular steroidogenesis and impacts the immune system. The reference ranges for prolactin are 3 to 14.7 nanograms per milliliter in males and 3.8 to 23 nanograms per milliliter in females. Increased prolactin levels may be caused by pituitary adenomas that produce prolactin, trauma, inflammation, chronic renal failure, and as a side effect of the administration of certain drugs, such as tricyclic antidepressants, phenothiazines, and reserpine. Hyperprolactinemia results in hypogonadism. Decreased prolactin levels may be caused by a tumor that compresses or replaces normal pituitary tissue. This is seen in panhypopituitarism, where there is a loss of all anterior pituitary function.